All right, for concept B, we're moving on to discovering some information about alkenes and alkynes. We talked in our previous concept about saturated hydrocarbon, which are the alkenes. Today we're going to focus on the unsaturated hydrocarbons, our alkenes and alkynes. So this is when we have a alkene is when we have a carbon-carbon double bond where our general formula is CnH2n. So if we have 6 carbons, that means that my formula is going to be C6H12. So only 12 hydrogens are needed when we have an alkene for a 6 carbon chain. So the ending of these are an ENE. We're going to be using a prefix to show the number of carbons in our main chain. And then the big difference between the alkanes that we talked about yesterday is we have to use a number to show the placement of the double bond. The lowest number of carbon touching the double bond always has to be identified. So we're going to be numbering our chains of carbons to discover which direction we want to number our chain in. So you always want to start counting the carbons from the side the double bond is closest to. So the double bond is closest to, in this case, the right-hand side. So we're going to place a 2 on the double bond, and then we can just finish counting the chain. So this, again, instead of we want a 2 placed on this, we're going to count right to left instead of getting a 1, 2, 3, 4 on the double bond. All right, counting from the left shows that the double bond is starting on the 4th carbon. However, counting from the right shows the double bond is starting on the 3rd carbon. This is the one that we want to use to name. So while this image isn't in your note packet, this is simply just to further illustrate that point about always checking from both directions so we can discover which way we need to number. Now, with 2 carbons and 3 carbons, we don't need to use a number. It's always going to be on the 1st carbon in the chain, whether we number it from left to right, depending on how it's set up. So here we have ethene, so we have 2 carbons with a double bond, and propene, 3 carbons with a double bond. Now when we get up to 4 carbons, now we need to use a number of either 1 or 2, depending on where the double bond is located. Both have the prefix but because they both have 4 carbons. They both have a double bond ENE, but the first one has the carbon double bond between the 1st carbon, and then the second 2-butene is located on the 2nd carbon. So again, using the number to show where that double bond is located in the chain. All right, here when we get up to 5 carbons, we have 1 pentene and 2 pentene. You can see here that we have the first one is on the 1st carbon, then followed by this one double bond being on the 2nd carbon. Now just realize that this is not 3-pentene, our last image here. This is simply a mirror image of the one before it. So you have to, again, be very careful, double checking both directions along the carbon chain. Alkynes simply have a triple bond along their carbon chain. We can use the general formula if we know we have 4 carbons, and we can plug that in as n is equal to 4 to discover that we have C4H6. Our ending is YNE. We have to also reflect the number of carbons using a prefix and use a number to show the placement of that triple bond along the carbon chain if we have 4 or more carbons. And just like before again, while I could have counted from the left and got a 5 on my triple bond, by counting on the right I get a 2, so I'm going to reflect that in the name. So again, I'm going to kind of quickly go through this as it's very similar to the alkenes. Alkynes, same thing. Our prefix is showing the number of carbons in the chain. YNE is giving us the triple bond that's located along it. 4 carbons, same idea. We're now showing that the first one has the triple bond on the 1st carbon, while the second image shows you in name shows you that we have a 2-butene, where this triple bond is located on the 2nd carbon. So again, numbering and making very clear where that triple bond is located. Same thing with 5 carbons. We have the numbers representing where the triple bond is, the pent representing the 5 carbons in the chain, and the YNE showing us that we have a triple bond located at that numbered carbon. So just some quick practice, try these out. You should see for this first one, we have a triple bond, we have 6 carbons, and the triple bond is located on the 2nd carbon, so 2-hexene. Here, a little bit different. I wanted to show you what a diene is. This is when we have 2 double bonds. So we would start with 8 carbons with the octa prefix, and then we're going to show that on the 1st and 3rd carbon we have double bonds. So here we have our 1st carbon or 3rd carbon, and then we can carefully fill in the hydrogens, making sure that carbon does not exceed 4 bonds around it. We can also use what we would call a line structure here to represent this. Each point or end of a line represents a carbon. So here we have our 1st carbon, 2nd carbon, 3rd carbon, 4th carbon, and going on. So sometimes you'll see this in terms of worksheets and that type of thing. So just start to become familiar with that. All right, the last little concept that I want to add on here is isomers. These have the same molecular formula, which means they have the same GFM, they have the same percent composition, but their structural formulas are different, which gives them completely different physical and chemical properties, so both physical and chemical. So here we have butane. We can have N-butane, which is kind of represents a normal butane structure with 4 carbons in a chain. And then isobutane, here we have 3 carbons in a chain with the 4th carbon coming off. They have the same exact molecular formula, but because their structural formulas are different, they have different physical and chemical properties. So which of the 4 structural formulas are isomers of each other? So take a second and try it out. The strategy that you would want to use is determining their molecular formula, so adding up the numbers of carbons, hydrogens, and oxygens. So going through and adding those together, even though they have different structural formulas, formula A and B have the same molecular formula. So these would be considered isomers of each other. The more carbons a molecule has, the more possible isomers that can be formed. So the more pieces, the more different combinations that you can make. All right, so that's it for alkenes, alkynes, and also isomers. So just make sure you got a basic handle on how to name those double and triple bonds in our carbon chains and how to identify isomers.